This video is about logs and log rules and how to rewrite logs, but it doesn't go as far as log equations. First, we'll start by looking at an example here of how logs and indices are just different versions of each other. If we have on the left here x is equal to log n to the base a, then that base a is the base here on the right hand side. N becomes essentially our final answer, and the x here is our index. So base a is base a whenever we rewrite it in indices, and then this x is our index. We can apply that to three different scenarios here. So on the left, if I have x is equal to log 4 to the base 2, rewriting that, base 2 to the power of x is equal to 4. Well then, if I want to find what x is, in this case I know that 2 squared is 4, so x is equal to 2. Similarly here, log 8 to the base a is equal to 3. Whenever I rewrite that, it's going to be a to the power of 3 is equal to 8. So in this case, the unknown is our base a, so we'll take the cube root of 8, which is 2. And finally here, whenever I rewrite log b to the base 3 is equal to 4, well then that's going to be 3 to the power of 4 is equal to b. So I'm just working out what 3 to the power of 4 is, which is 81. Now on to the laws of logs, and these allow us to rewrite logs. So if I have log of a times b in brackets, well then I can separate that into two separate logs that are added together. So log of a times b is equal to log a plus log b. Log of a divided by b in a bracket, I can separate that into two separate logs, but with a subtraction, where it's log a subtract log b. And finally, log a to the power of n, I can rewrite that as n log a. Notice that when we say log without a base, that means that it's log to the base 10. Another law that will come in useful is that whenever we have log a to the base a, or log b to the base b, if it's the same letter, well then the answer is going to be 1, since rearranging a to the power of 1 has to give us a. Just seeing these laws of logs in action here, that is just the first law, which is log of a times b can be split up into log a plus log b. But if I have something like log a squared b, well then I'm going to have two separate logs that are added together. One will have a, one will have b. But this 2 here means that the first log is log a squared. Now, from the laws of logs, I can rewrite that as 2 log a. The third one here, I have a and b, so I'm going to have two separate logs with a subtraction. But because there's a b squared on the bottom, that's going to be subtract log b squared, which can be then rewritten as 2 log b. The fourth one, I have an a b, and a c. We'll come back to what this power of 4 is going to do, but because I have 3 letters here, I'm going to have 3 logs. The m and the b are going to be an addition of logs. And because we're dividing by c here, I'm going to have a subtraction of log c. So it's going to be log a plus log b to the power of 4, subtract log c, and then this middle log can be rewritten as 4 log b. And the fifth one here, 2 letters, which means we're going to have 2 logs. They're being divided, so there's going to be a subtraction. Now a and c cubed are all underneath the square root, which means that they're going to be raised to the power of a half. So my first log is going to be log a to the power of a half, which can be rewritten as a half log a. My second log, which is going to be subtracted because there's a division, is going to be log c to the power of 3 over 2, because over here is c cubed, but whenever we raise that to the power of a half, we multiply the indices to get 3 over 2. So then rewriting that is going to be 3 over 2 log c. Now we're going to write logs in numbers, logs of numbers in terms of other logs of prime numbers. So there's going to be questions where you will be given something like this. So if log 3 is equal to p and log 2 is equal to q, we have to express the following in terms of p and q, using what we know about the rules of logs. So log 6 can be expressed as the log of 2 times 3, which can then be expressed as the log of 2 plus the log of 3. And because these are in our question, log 2 is q and log 3 is p, the answer is q plus p. The second one, log 8, well I can express that as 2 cubed, which can be then written as 3 log 2, which is 3q, because q is log 2. The third one here, 72 can be rewritten using a product of primes as 2 cubed by 3 squared. So therefore the log of 72 can be written as the log of 2 cubed plus the log of 3 squared. Bring these indices to the front of the logs, 3 log 2 plus 2 log 3. Then our answer is 3q plus 2p. The previous questions were all log to the base 10, but what if there's a log to the base of a different number? And in these examples here, we're given if log 2 to the base 3 is equal to p and log 5 to the base 3 is equal to q, well then we're going to have to rewrite these logs in the questions. Now notice that because we have log to the base 3, if we see log 3 to the base 3, well then we can rewrite that as 1. So if we can express these numbers in the questions as products of 2, 5 and 3, well then we can get our final answer. For example here, log 10 to the base 3, 10 can be expressed as 2 times 5, so that can be expressed as log 2 to the base 3 plus log 5 to the base 3, which is p plus q. 20 can be expressed as 2 squared by 5, so log 20 to the base 3 can be expressed as log 2 squared to the base 3 plus log 5 to the base 3, and you can rearrange the first log to be 2 log 2 plus log 5 both to the base 3, which is 2p plus q. And the last one is just an illustration of using log 3 to the base 3, because 6 can be expressed as 2 times 3, so then I can have log 2 to the base 3 plus log 3 to the base 3, so this is equal to p in our question, but this is equal to 1, so our answer is p plus 1.